This video includes two examples of an application of the law of sines. One example will have one solution, and the other example will have no solution. For the first example that will have one solution, we're given that angle A equals 24 degrees, angle B equals 80 degrees, and side C equals 20. So the first thing I did was draw on a diagram, because if I draw a diagram I can kind of see what I'm working with, and then I can set up my proportions for my law of sines. So the first thing I want to notice is that I need to find angle C as well, and that I can do really easily without using the law of sines, because I know the sum of all of the angles in my triangle needs to be 180 degrees, so my angle C is 180 degrees minus 80 degrees minus 24 degrees, which gives us 76 degrees. So I'm just going to update my diagram to reflect that information. Now I'm going to set out the kind of bare bones model of the law of sines and fill in the information that I know. So this is the law, and I'm just going to fill in the information that was given in my problem and the value of our angle C, which we've already found. Right now, I don't have enough information to use this proportion here because I'll have two unknowns, so A and B are both unknowns. However, I can use this proportion, so my B and my C portion of my law of cosines, or my law of sines, to solve for B. So that's what I'm going to do. So the first thing I do is multiply to clear my denominators, and now I can divide to isolate B. I punch that into my calculator, and then I get that B is approximately 20.30. So I'm going to update my diagram to reflect that information, as well as my law of sines here at the top, where I've just kind of been filling in the information as we get it. Now, the only unknown left in our triangle is side A, so I can take this ratio for A and set it equal to B, or I can set it equal to the ratio for my C's here. So, since they're already next to each other, I'm just going to go ahead and use this proportion to solve for my side A. Once again, I just need to cross multiply and divide to isolate A. And after popping that in my calculator, I get the length of my side A is approximately 8.38. Once again, I can just throw that in my diagram, and we've solved for all of the missing information for this triangle. So that is how an example of a law of sines problem with one solution might look. Now, just a quick note here. If we notice the original given information here is in the dark blue, we have an angle, and the included side. So this was an example of angle, side, angle problem. This is an example of a law of sines problem with no solution. Our given information is that angle A equals 60 degrees, side A equals 2, and side B equals 10. So once again, the first thing I'm going to do is draw a diagram to kind of make sense of this information. Now, just a note, when I draw my diagrams, I don't worry about trying to make them to scale or anything. I just kind of draw in a triangle and fill in the variables. So I just remember that your angle A is across from side A, angle C is across from side C, etc. The accuracy of your diagram will not affect the accuracy of your algebra when you're actually applying the law of sines. So once again, this is just my model for my law of sines. I'm going to fill in the information that I already know. It's kind of clear from this setup that in order to solve for angle B, I need to use this proportion right here. And luckily, they give us that angle A is 60. So we know the sine of 60 from our unit circle is root 3 over 2. So root 3 over 2 divided by 2 gives us root 3 over 4. And we can just set that equal to sine B over 10. I multiply both sides by 10. And now, to isolate B, I need to apply sine inverse to both sides so I can cancel this sine. So I get the sine inverse of 5 times root 3 over 2 equals my angle B. Now, if I go plug this into my calculator, I'm going to get an error message. If we go to our unit circle here, remember, y equals sine of theta. And on our unit circle, the largest y value we can have is a positive 1. So that means for our sine inverse function, our inputs can't be any larger than 1. Now, of course, this right here, 5 times root 3 over 2, is greater than 1. Therefore, it is not within the domain of the sine inverse function, and we can't actually have an angle B with the sine inverse being 5 times root 3 over 2. Or rather, an angle B with a value of sine inverse 5 root 3 over 2. Excuse me. Hence, we have no solution. And just for good practice, let's go ahead and identify the given information that we have. So we have the length of a side, and then the value of an angle. So this was a side-side angle problem.